These are 4 important facts that you need to learn. So you can only use binomial if you've got a fixed number of trials, if there are 2 possible outcomes, usually the thing you want and it not happening, a fixed probability of success so that after you've done something once, the probability doesn't change. So if you're playing a game, you never get any better or any worse at it, you have the same probability every time. And the trials are independent, so how you performed last time doesn't affect how you perform the next time. This is the notation, x squiggle b n p, and we write the probability like this. So we're going to be working with menu 7, and for equal to, we're going to use number 4, binomial PD, and we're always going to pick variable. Then all we need to do is slot the information in. So x is 2, n in this case is 12, probability is 1/6, which the calculator can deal with in fraction form or decimal. Ask it the answer and it tells you what it is. Standard rounding is 3 significant figures. If we change this to 9, a very small probability. Less than or equal to, we can either use this same, because less than or equal to 1 means it could be 0 or it could be 1. So we can work out both of those and then add them together. So 0 has a probability of, I can store in my calculator, and 1 has a probability which again I can store into my calculator, and back to menu 1 I can add up those 2 results. We don't use the PD very often because it's not often we want to know it's exactly something. Often we want to know more or less, which we will come on to next. So here's an example written out, and we need to convert the information in the text into the symbols that we've just been working with. So we've got it as a binomial. We're told there are 20 members, so that's my sample size, and the probability is 0.15. And I want to know the probability that exactly 7, so it's going to equal 7, is left-handed. So menu 7, number 4 binomial PD, number 2 variable, x is 7, n is 20, p is 0.15, and the calculator then tells me it's 0.0160. Probability that fewer than 2, so that means either none or 1, are left-handed, so we can do this as we did before. So 0, store into A, 1, store into B, menu 1, and then add them up. This method is fine provided the number of results you're having to add up is quite small. If you're having to add up a lot of results, then we use instead menu 7 and we scroll down and we use binomial CD. This is the cumulative, and the cumulative only works for less than or equal to. It doesn't do strictly less than, it doesn't do greater than. So we'll need to adjust everything we're being asked into a less than or equal to. So this first one is easy enough. So the x is 7, n is 20, p is 0.4, and the calculator just gives me the answer. Less than 6 is the same as less than or equal to 5. Because we're dealing with integers, whole numbers, so 1, 2, 3, 4, 5, 6, 7. If I want those numbers that are strictly less than 6, so I'm not including 6, it's all the numbers from 5 and below, so less than or equal to 5. This I can then get the calculator to work out straight away. Greater than or equal to 15, well, that's 15, 16, 17, 18, 19 and 20. So that's everything that's not 14 and below. So it's 1 minus x less than or equal to 14. We can't put 15 in the calculator, it'll only tell me less than. So if I put 14 in, it tells me the probability it's less than that, so 1 minus that will be what's left. So 1 minus, store that into A, menu 1, 1 minus that answer is So whenever we're using the binomial CD on the calculator, we need to be able to interpret the phrase into what we need to put into the calculator. So greater than 5 doesn't include 5, that would be 6, 7, 8. Which means we can't do greater than, but we can do less than, so it's 1 minus less than or equal to 5, because it's not 5, 4, 3, 2, 1. No more than 3, so it can be less than 3, so it can be 0, 1, 2. It can be 3, but not more than 3, so it can't be 4. So this is less than or equal to 3. At least 7 includes 7, and then anything above that. So again, we've got a greater than situation, so it's 1 minus, not 7, but 6 and below. Fewer than 10 doesn't include 10. 10 is 10, it's not fewer than 10. So this is less than or equal to 9, even though the question says 10. At most 8, so 8 is our upper limit. So this is less than or equal to 8. So a useful table to have for greater than, no more than, at least, fewer than, at most. What each of these phrases means in terms of the binomial we're going to put into our calculators. So here I've got a binomial distribution, 12 spins with a probability of 0.3. No more than, so no more than is less than or equal to, so I want the probability it's less than or equal to 2. So I can just, number 7, scroll down, number 1, number 2, x is 2, 12 trials, 0.3 probability, is 0.253. At least 5, at least 7 was 1 minus less than 6, so at least 5 will be 1 minus less than or equal to 4. So x is 4. Store that in A. 1 minus that answer. 1 minus that answer is 0.276. Right, this time we've got an unknown amount of reds. So the probability of winning a prize, you must have lots of reds. If you get more than a certain number of reds, you will get a prize, but she wants that probability to be less than 0.05. We can't do a greater than probability, so we need to rewrite this as 1 minus less than or equal to 1 less. We look at that as the at least 7, because she needs to have at least so many successes. We write it as 1 minus 1 less than 7. That's why I've done A minus 1. That's got to be less than 0.05. If we rearrange, we discover that the probability needs to be greater than 0.95. So we've got binomial, 12 spins, and the probability is still 0.3. And we're going to find A just by trial and error. Actually, we're going to find A minus 1. So menu, 7, scroll down, binomial CD. Probably going to be more than half, so 6, 12, 0.3. That's 0.96, so yes, that would do. What happens if I did 5? If you had 5 reds, it's not high enough, so A minus 1 must be 6, so A itself must be 7. You need 7 or more to get a prize.